NASA is a space agency. It has thousands of employees, a budget in the tens of billions, and its entire stated reason for existing is to explore what lies beyond Earth. So when scientists at NASA's Jet Propulsion Laboratory pointed their cameras and robots downward instead of upward, toward the bottom of our own ocean, the question writes itself. What were they looking for down there? The answer is that they were looking for proof that life can survive without any sunlight at all, and they found it. What they found under the ocean floor also changed what scientists believe about where life might exist in the rest of the solar system. And the specific research programs that dove the deepest into those questions have since been quietly wound down, defunded, or dismantled. This is what they found before that happened. But before any of that, you need to understand something most people have completely wrong about the ocean itself. What we actually know about the ocean. Most people assume the ocean is mostly explored. We have been sailing across it for thousands of years. We have maps of the seafloor. We have submarines and satellites and sonar. It feels like a solved problem. It is not even close to solved. A study published in the journal Science Advances went back through every recorded deep-sea dive in history and calculated exactly how much of the deep ocean floor humans have actually laid eyes on. They tallied more than 43,000 trips down into the deep, going all the way back to 1958. The total area those dives had visually covered was less than 0.001% of the deep sea floor. The area humans have actually seen at depth is roughly the size of the state of Rhode Island. The deep ocean itself covers more than 2/3 of the entire planet's surface. To put that in terms that feel real, we have better maps of the surface of Mars than we have of our own ocean floor. More people have traveled to space than have descended to the deepest part of the ocean. And almost all the dives that have been done were clustered near the United States, Japan, and New Zealand, meaning enormous stretches of the global ocean remain completely unseen. The Indian Ocean, one of the 3 major ocean basins on Earth, is described by researchers as one of the least explored areas on the entire planet. Scientists estimate there may be between 700,000 and 1 million species living in the ocean, and roughly 2/3 of them have never been discovered or officially described. Nearly 2,000 new ocean species are accepted by the scientific community every single year, and that pace has not slowed down. Every time a research vessel goes somewhere new, it finds something that was not on any list. That is the backdrop against which NASA decided to go looking. And what they found when they got down there changed the most fundamental assumption in all of biology. The day life rewrote the rules. Before 1977, the scientific understanding of life on Earth rested on a single principle that nobody seriously questioned. All life depends on sunlight. Plants absorb it and convert it into energy. Animals eat the plants or eat the animals that ate the plants. Every ecosystem traces its energy back to the sun in one way or another. This was not a fringe theory, it was bedrock. It had never been seriously challenged because there had never been a reason to challenge it. In February 1977, a team of scientists aboard the research vessel Noor sailed to an underwater ridge called the Galapagos Rift, about 400 miles off the coast of Ecuador. They were geologists looking for evidence of underwater volcanic activity. There were no biologists on the expedition because nobody expected to find anything alive. The deep ocean at that depth was assumed to be a cold, lightless desert with essentially nothing in it. What they found instead was an oasis. Superheated water was shooting out of cracks in the seafloor at temperatures that would kill a human being in seconds. The pressure at that depth would crush a submarine. There was absolutely no sunlight, and surrounding those cracks was a dense, thriving community of creatures unlike anything science had ever seen. Giant clams the size of dinner plates. tube worms taller than a grown man, strange shrimp and crabs and pale fish, all clustered around vents that looked like underwater geysers spewing dark mineral clouds into the water above them. The bacteria at the base of the food chain were performing a process called chemosynthesis. Instead of using sunlight to convert carbon dioxide into food the way plants do, they were using the toxic, sulfur-rich chemicals pouring out of the vents. Everything else in the ecosystem ate those bacteria. The entire food chain ran not on sunlight, but on the heat and chemistry of the Earth itself. Up until that day, science had assumed that all life on Earth was in some way dependent on the sun. The discovery of hydrothermal vents ended that assumption permanently. Life did not need the sun, it needed chemistry and heat, and those are available in a lot more places than sunlight is. That realization is exactly what made NASA interested, and it is what sent their researchers to the bottom of the sea. Why a space agency went underwater. Jupiter has a moon called Europa. Saturn has a moon called Enceladus. Both of these moons have liquid oceans beneath thick shells of ice. Europa's ocean is estimated to contain more liquid water than all of Earth's oceans combined. Enceladus has been observed actively venting water vapor out of cracks in its icy surface, which means its ocean is interacting with its rocky seafloor in real time. Scientists believe the seafloors of both moons may have hydrothermal activity, hot water mixing with rock in total darkness, exactly the conditions that produce thriving life at the bottom of Earth's ocean. The 1977 discovery made those moons the most exciting targets in the search for extraterrestrial life. If life can survive without sunlight at the bottom of Earth's ocean, then there is a real chance something is alive in the dark oceans of Europa and Enceladus right now. To prepare for eventual missions to those moons, NASA needed to understand exactly how deep ocean hydrothermal systems work. In 2018, NASA joined a 3-year research program called SubSea, Systematic Underwater Biogeochemical Science and Exploration Analog. The first target was a still-forming underwater volcano called the Loihi Seamount, sitting off the coast of Hawaii more than 3,000 feet beneath the surface. In 2019, the team moved to the Gorda Ridge, about 75 miles off the California and Oregon coast. Both locations were chosen because the temperature, pressure, and chemical conditions there closely matched what scientists expect to find on the seafloor of Enceladus. The goal was to figure out what instruments would be needed to detect life in those conditions, and what signatures a living system leaves behind in the water and rock around it. The research was not really about Earth's ocean. It was a rehearsal for a mission that has not happened yet. Before we move on, if you're enjoying this analysis, please consider subscribing. It helps the channel tremendously. And then a different NASA-funded expedition found something in the Caribbean that surprised even the scientists who were expecting surprises. The deepest place anyone has ever found life. In October 2009, a research team that included scientists from NASA's Jet Propulsion Laboratory sailed into the Western Caribbean Sea. Their target was an underwater volcanic ridge called the Mid-Cayman Rise, running through the Cayman Trough, the deepest point in the entire Caribbean Sea. On a ridge this size, they expected to find one vent site, maybe two. What they found instead was 3, and each one was a completely different type. One of those vent sites sat nearly 5,000 meters below the surface, almost 3.5 miles down. The fluids spewing from those vents reached temperatures of around 400 degrees Celsius, hot enough to melt lead. The Jet Propulsion Laboratory researcher on the expedition made the point directly. These vents support communities of organisms that are the furthest from the ocean surface and from any source of energy like sunlight that exist anywhere on Earth. They are also, he noted, the kinds of environments NASA expects to find on the seafloor of Europa. The chief scientist described finding 3 completely different vent types in one small area, including one that matched a rare style seen only once before in the entire world, as something nobody had predicted going in. The scientific paper was published in the Proceedings of the National Academy of Sciences. This was NASA-funded science with NASA researchers attached, and it produced one of the most extreme documented living environments on the planet. What nobody had yet checked was what was hiding underneath those vents. The ecosystem. Nobody thought to look for. For 46 years after the first hydrothermal vents were discovered, scientists studied them extensively. They cataloged the animals, mapped the chemistry, and described hundreds of new species. The picture seemed reasonably complete. Then in the summer of 2023, a research team, led by Dr. Monica Bright of the University of Vienna, went to a well-studied vent site on the East Pacific Rise, 2,500 meters below the Pacific Ocean. One idea had been nagging at the researchers. The young of tube worms, which are among the foundational animals at every vent site, were almost never found in the water above the vents. Where were the larvae going? They used the robotic arm of their underwater vehicle to flip over chunks of the seafloor and look underneath. What they found was an entire hidden world. Beneath the seafloor, carved through volcanic rock by the flow of vent fluid, were cave systems full of warm water sitting at around 25 degrees Celsius. Inside those caves were worms, snails, larvae, and a layered microbial community that had never been seen by any scientist. The tube worm larvae were there. The animals were using the subsurface cave network to travel between vent sites, colonizing new areas through the rock itself rather than through the open water above. Scientists had spent nearly half a century studying these vent systems from above without once flipping over the floor to check what was living underneath it. Scientists not involved in the expedition pointed out immediately that if this is happening at one vent site, it is almost certainly happening at all of them, which means there is a hidden layer of the deep ocean biosphere that science simply never thought to look for. The total amount of life in the deep ocean may be significantly larger than any previous estimate had accounted for. This discovery was published in the journal Nature in 2024, and it was one more piece of evidence that the deep ocean is not just strange, it is actively full of life in places nobody was looking. Then came the finding that may have upended one of the oldest beliefs in all of science. Oxygen without sunlight. Every biology class teaches the same fact from the very beginning. Oxygen comes from photosynthesis, and photosynthesis requires sunlight. About half of every breath you take was produced by phytoplankton near the ocean surface. The other half came from plants on land. Both processes run on sunlight. That rule had never had an exception, until 2024. Professor Andrew Sweetman at the Scottish Association for Marine Science first noticed something wrong with his data in 2013. He was measuring oxygen levels in sediment on the seafloor of the Pacific Ocean in a region called the Clarion-Clipperton Zone, about 4,000 meters down. The oxygen readings were going up instead of down. In deep water with no sunlight, oxygen levels are supposed to fall as organisms consume it. He assumed his instruments were broken. He got the equipment recalibrated. He repeated the experiment. The readings kept coming back the same. He spent years running variations of the same test, getting different colleagues to check his methodology before accepting what the numbers were saying. Something at the bottom of the Pacific Ocean was producing oxygen without any sunlight at all. It took nearly a decade from the first reading to the published paper because the finding was so far outside what anyone believed was possible. His team published their findings in Nature Geoscience in the summer of 2024. The source turned out to be potato-sized lumps of rock called polymetallic nodules, dense in metals including manganese, cobalt, and nickel. These nodules carry an electric charge comparable in voltage to a household AA battery, and that charge is strong enough to split seawater into hydrogen and oxygen through a process called electrolysis. The rocks are producing oxygen the way a battery powers a device, with no biology involved and no sunlight required. Sweetman said in the published paper that scientists now need to revisit the most basic questions about where aerobic life could have begun on Earth. Researchers at Boston University pointed out the direct connection. Europa and Enceladus have no sunlight reaching their subsurface oceans. But if metal-rich rocks under those oceans are doing what the Clarion-Clipperton nodules are doing on Earth's floor, there could be oxygen production happening right now in those dark oceans, supporting life that nobody has looked for yet. Then the research started getting cut. Why the looking is stopping. The subsea program ran for 3 years and then ended. NASA has continued some ocean-related research from space, including the 2024 launch of the PACE satellite, which studies ocean ecosystems from orbit, but the hands-on deep-sea analog work that most directly connected ocean floor exploration to the search for extraterrestrial life did not get a follow-up program of comparable scale. The deeper issue is what has happened to NOAA, the federal body most directly responsible for exploring the American ocean. In 2025, its budget was targeted for cuts of more than $1.5 billion, representing nearly a quarter of its total funding. Hundreds of employees were fired. Grants to university research programs were terminated. The specific line item for ocean exploration and research was reduced by $21 million. Programs focused on ocean acidification, coral reef conservation, and coastal zone management were marked for elimination. Then in June 2025, the National Science Foundation announced it would begin removing the instruments of the Ocean Observatory's initiative from the seafloor. The OOI was a network of more than 900 advanced sensors placed on the ocean floor a decade earlier, costing $370 million to install and designed to run for 25 years, providing continuous real-time data about ocean temperature, chemistry, currents, and ecosystems. The instruments were pulling data from the waters off Oregon and Washington, off Alaska, off the North Carolina coast, and from the Erminger Sea between Greenland and Iceland, a stretch of ocean that plays a critical role in global climate circulation. The decommissioning was directly in line with recommendations in the Project 2025 policy document, which described the network as a source of climate alarmism and advised that its research should be disbanded. Craig McLean, who served as NOAA's chief scientist, said publicly that dismantling such a system pushed the United States back into a rear seat in global scientific leadership. A biological oceanographer at the Plymouth Marine Laboratory described sustained ocean observations as how scientists detect emerging risks in real time, and said that removing them means choosing to navigate an increasingly unpredictable ocean with less and less information about what is happening in it. What this adds up to: NASA did not stop exploring the ocean because of something they found. That story, which spread widely online, is not accurate. What actually happened is more complicated and more significant. A space agency went into the deep ocean to prepare for missions to the moons of other planets. What they found down there kept producing discoveries nobody predicted. Life thriving with no sunlight, a hidden ecosystem living inside the rock beneath an ecosystem studied for decades. Oxygen being produced by rocks in total darkness in a way no textbook had ever described. Each of those findings changed the scientific understanding of where life can exist and pointed toward the same conclusion. We have explored almost none of the most extreme and interesting environments on our own planet. The ocean is not a backdrop. It is an active frontier, and it keeps producing results that rewrite the rules every time someone looks somewhere new. Less than 0.001% of the deep ocean floor has ever been seen. What has been seen in that fraction has already rewritten the rules about life, oxygen, and the limits of biology. The question of what exists in the remaining 99.999% is still completely open. And right now, fewer people are looking than at any point in the last decade. If you got something out of this video, Subscribing takes about 3 seconds, and it genuinely helps us keep making these.